All right, where we're going to go in chapter 10 is what we call conics. And the first type of conic we're going to deal with is what's called the circle. Actually, should be quite a bit of review for you. You dealt with this in geometry. So, number one, our definition for a circle is a set of all points equal distance from a given point. So that given point where we're starting is my center. So for every circle, we need to know where the center is. And a lot of times what they'll do is they'll label it with a capital C. That equal distance piece, okay? When I talk about all points, okay, so there's a point here, there's a point here, there's a point here, but that distance from the center to each of those points again is what we call your radius. Okay. Other parts that you should remember in terms of circles is that if I have a chord, okay, that goes through the center of the circle, it's called a diameter. Okay. Chord again is the idea that I have a segment where my endpoints are on the circle. Okay. The idea again is your diameter is the same as 2 of your radius or radii, and that if I knew my radius, it was half my diameter. Okay. All right, so what we have then, and we're going to work with these equations of circles and these other conics as we move along, and we have a standard form. And with our standard form, what we have is x minus h, that quantity all squared, plus y minus k, that quantity all squared is going to be equal to your radius squared. Okay. The h and k pieces tell me where to find my center. Okay. The radius comes from the r. Now, a couple things to recognize here. Notice how all we're going to be doing, and we've talked about this before, is when I go from standard form into an ordered pair or vice versa, my signs are going to change. So if I had an x minus 2, okay, in the center, it would be a positive 2, because what I'm doing is asking what's being subtracted from x. Y plus 4, okay, well, that's going to be the opposite. It's going to be a negative 4 because of the fact that's y minus negative 4. Okay, and we're wondering, what am I subtracting from y? And it's a negative 4. So it's just really changing signs. The thing with the radius to be careful of is, notice again, it's r squared. Okay, so if it were 8, your radius then is the square root of 8. If we did ask you to simplify 2 square roots of 2, I'd rather not have you changing them to decimal values, because as soon as you change them to decimal, again, square root of 8 is irrational, so we're rounding it off. Okay, and so there's some error. We want exact values. All right, so if I'm asked to graph, very simple situation, number one, where's my center? Okay, so my center, opposite of what's being done to the x, opposite of what's being done to the y. So my center here is at 4, negative 3. Second thing I want to find then is the length of my radius. Okay. Well, r squared is 25. So if I take the square root of both sides, I get plus or minus 5. But again, because of the fact that we're talking about a distance, it can only be that positive 5. Now, I need a set of all points 5 units away from my center. Well, the easy ones are going to be if I go to the right 5, left 5, up 5, and down 5. And it's kind of hard to go at a diagonal here. And then from there, what we want to do is just kind of do the best job we can in terms of sketching our circle. And so there you have it. Pretty simple situation. Now, what we also have is what's called the general form. Okay, we have ax squared plus by squared plus dx plus ey plus f. Okay, meaning that we could have, or we will have, in an equation for a circle, a x squared piece, a quadratic in the x, a quadratic for the y, a linear for the x, linear for the y, and then also a constant. Now, the key for me when it's in this general form that tells me that it's going to be a circle is that a and b. The quadratic coefficients are equal. Okay, that's how I know it's a circle. So if they're not equal, I don't have a circle, I have a different situation, which we'll build on as we go through this chapter. Okay, so here's my equation that I want to graph this time. 2x squared plus 2y squared minus 4x plus 12y minus 18. So it's in that general form. I need to first get it into standard form. Now notice, this is how I know it's a circle. X squared and y squared have the same value. They're equal. All right, so there's a process that we call completing the square that we're going to use here. Okay, the number one thing we have to do when we complete the square is we need to put our x stuff together, put our y stuff together, and take our constant to the opposite side. So what I did was simply take the 4x piece and move it over here along with the sign to get my x pieces together. And then I put the y squared over here so it's with the 12y. And then what I also did was I threw the 18 to the other side, and again, change sides, change signs. And so now I'm in that first step. X stuff together, y stuff together, constant alone. Okay. Second step, what we want to do is get my quadratic coefficients to be equal to 1. Okay. This is easy with the circle because since a and b are the same, we're going to divide out that value that the coefficient is taken on. So I'm going to divide out 2. But again, we got to divide it out of everybody. I can't just divide it out of a couple pieces. Okay, each piece needs to be divided out by 2. And so what I have then is 1x squared, negative 2x, 1y squared, 6y, and 9. Okay. Now, here comes the piece that causes some problems once in a while. Step number 3, I need to add half my linear coefficient squared to both sides. Now, I'm talking about the linear coefficient for the x's and for the y's. Okay. So what we're saying is I want to take half my linear coefficient. So I'm going to take half of negative 2, which is going to be negative 1. And then what I want to do is square it. Okay. I'm going to add that to both sides. Okay, and I'll get that in a second here. I want to do the same thing to my y's. Okay, so my y, my coefficient is 6, so I'm going to take half of 6, which is going to give me 3. I'm going to square that, and I'm going to add it to both sides. Now notice again, both times we squared, we get a positive value. Okay, that's a common error. Sometimes people will square a negative, and they'll keep it negative. So there's the 1 for the x. So I added it here, and I added it there. The 9 that I got by squaring half my linear term of the y's, added that to both sides. Because again, you got to keep that balance for your equations. Now, I grouped them into trinomials because what I'm going to do now is I'm going to rewrite these as perfect binomial squares, and this is going to happen every time. Okay, what's going to happen is I'm going to have something that's in the form ax squared plus bx plus c. But again, the idea is we've already gotten rid of this, so it's 1x squared, and it's going to be a perfect square. So it's going to be x plus or minus something all squared. Okay. So if I thought about factoring x squared minus 2x plus 1, I'm looking for two numbers that multiply to 1 and add to negative 2. Well, the only way I can get 1 is 1 times 1, or negative 1 times negative 1. So there's my pair. Notice what I took half of. This is the same thing as x minus 1 times x minus 1. Okay, there's my perfect binomial square. If If I think about this one, two numbers that multiply to 9, add to 6. 3 and 3. So what's going on is these numbers are getting used yet again when I go in and rewrite them as a perfect binomial square. Okay. The right side, 9 plus 1 plus 9, there's my 19. Now we're all set. I can pull out my center and I can find my radius. And if I were to graph this, I'd plot my center, and square root of 19 is 4 point something, so that's what I would use as an estimate to plot those points. All right, last piece we need to do is write an equation. Okay, sometimes really easy. In this case, when they give you the center, give you the radius. Okay, so here's my center at 7, negative 2, radius of 8. Well, x minus that x piece. So notice again, we changed from positive 7 to negative 7. Plus y minus the y value, y minus negative 2, positive 2. Notice again, it changed signs, squared. And the piece we got to be careful of that gets forgotten from time to time is that you got to make sure you square the radius. Okay. Now another situation that will come up is they may give you parts of a circle. So in this situation, they told you the endpoints of your diameter are 4, negative 9, and negative 6, 3. Well, what I need to do is use my midpoint formula. Okay, to find that center. Okay, so when I take the 4 and the negative 6, I get negative 2. Divided by 2 is negative 1. Negative 9 plus 3 is negative 6. Divided by 2. So now I have my center. Okay, so x minus the x piece, but again we're changing signs, y plus 3. Now, to get your radius, you're going to need your distance formula. Oops, sorry. It's minus, so think in the midpoint formula. Okay. And what you're going to do is you're going to have to pick two of the points. Obviously, you want the center and then one of the points on your diameter. And so then we'll plug those values in. So negative 1 minus 4 all squared plus negative 3 minus a negative 9, so plus 9 squared. This is going to become 5 squared or negative 5 squared, so 25. Plus that's going to be 6, so 36. So the square root of 61. Okay, that's that distance. Don't confuse this with diameter because we're using d. So remember though, it's your radius squared. So because it's my radius squared, the square and the square root multiply out, equation written. Okay. Here's that midpoint formula again in case it was not easy enough to see. All right, so good luck with that.